Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AFFIQ bin RUZIAN. My method number is 194196. I am from the mechanical engineering. So today I would like to present about my final year project presentation, which is computational fluid dynamics, simulation and experimental analysis of liquid separation process by gravitational force particle separator. This project study is focused on the background of palm oil based polyol for polyurethane development, including cosmetic product. For the purpose of analysis, second liquid solvent is introduced in this separation step. The problem statement of the project is the moisture content is vital in determining the quality of fine bleach deodorant palm oil. Moisture content could affect the further synthesizing activity and disturb the chemical formulation during processing. Next, rotating pack bed was designed to enable the fluid flowing through the packing. However, rotating pack bed rotate quickly and difficult to describe the fluid flow topology. Hence, a non-rotating pack bed was recommended. The objective of the project firstly is to determine the moisture content of water in mixture by utilizing the glycerol solvent that acts as dehydrating agent to extract water from RBGPO in liquid separation. Next, to validate the computational fluid dynamic result of moisture content by experimental with using Teflon as packing material. Then, to analyze fluid flow behavior in the column of gravitational force particle separator by using CFD simulation for variation of fluid mass flow. The scope of study only focus on the separation of liquid using RBDPO and water. Then the utilization of two different solid packing material which involve steel and Teflon. Then the SolidWorks and the ANSYS was involved for the software. So next move to the methodology. So this is the flowchart for the project. The left hand side is for the experimental procedure, meanwhile the right hand side is the simulation procedure. So this is the geometry of packing. It was designed in solid. So this is the machine sensitivity analysis. Now this is the figure for the first column reactor, and this is the properties of fluid used experiment. Then this is the second column reactor. At the end of the product, there are two layers which represent polyol and the glycerin. Then the moisture content was indicated by using the Metrohm 784 KFP titanium moisture content indicator. So the real discussion for this project is this is the experimental result of moisture content obtained. So we can calculate the average volume, which is the 0.5244 milliliter. So this is the simulation result for the volume of fluid for mass flow rate 0.00083 kg per second. So and this is the summarized volume of fluid based on the figure here. Then this is the volume of fluid for mass flow rate of 0.0083 kg per second. So what can we get in this project? The moisture content before separation is 2%, while after separation is 1%. According to standard, the moisture content standard is limit to 0.1% limit. However, the moisture content of RDPO is higher than the standard, since the experimental preparation is not identical due to the high technology with high expense. So this is the graph of the cell Reynolds number. So this is the percentage error by calculating the average water volume in experiment and simulation. So in this project, the percent error for the project is 25.45%. So this is the Reynolds. What can we get if from the previous figure is the low Reynolds number. So in the case of Reynolds number greater than 1, the initial coalescence takes place. Based on previous research, when the Reynolds number greater than 1, turbulence may occur. So what can we conclude? That at position 0 to 0.0325 meter, the fluid condition is laminar, since the Reynolds number is less than 1. Meanwhile, at position at the outlet region, the condition is turbulent flow. So this is the comparison of simulation result between two different packing material, which is steel and Teflon. So what can we see, that the steel consists of volume average of greater than the Teflon volume average. So for the conclusion is, steel packing showed a bit higher in volume average water than Teflon packing, but this is only different by only 0.00024 milliliter. Hence the steel packing is recommended. So the figure here shows the surface energy of Teflon and the stainless steel. So what can we obtain from the figure here is, the surface energy of stainless steel is greater than the surface energy, hence the steel packing is recommended. So the overall conclusion for the project is, glycerin is an effective solvent that acts as dehydrating agent to extract water from RBDPO by separation and coalescence process, thus improve the moisture content in RBDPO. So that's all from me. Thank you.